Today, we are looking at IB physics density. Calculate mass from density and volume, then apply it to a real exam question. In this lesson, we are learning density. Density tells us how much mass is packed into a given volume. The whole method is built around one simple relationship. Density equals mass divided by volume. First, find the volume. For an irregular object, use displacement. Measure the starting volume in the cylinder, then add the object and measure the final volume. The object's volume is final volume minus initial volume. Next, measure the mass using a balance. Keep the number clear and keep the unit with it. In this example, the object's mass is 81.0 grams. Now substitute into the formula. The mass is 81.0 grams and the volume is 30 milliliters. So density is 81.0 divided by 30, which gives 2.70 grams per milliliter. The exam mark is often lost on units. Mass might be in grams or kilograms. Volume might be in milliliters, cubic centimeters, or cubic meters. Your density unit must match the units you used in the calculation. So the checklist is simple. Identify the mass, find the volume, divide mass by volume, and write the correct unit. In the next section, we can use real EduNinja exam questions from this density topic to practice the same steps. Now, let's apply density to a real exam-style question. The question asks us to show that the mass of an iceberg is about 1.2 times 10 to the 9 kilograms. So this is not a guess the answer question. It is asking us to show the working that gets close to that value. The key idea is density. If density is mass divided by volume, then mass is density multiplied by volume. So our plan is simple. Find the volume of the iceberg, then multiply it by the density of ice. The mark scheme gives the floating ratio step. Using the densities of ice and seawater, the iceberg height comes out to about 300 meters. This is the part students often miss. Before calculating mass, we need a usable volume. Now substitute into mass equals density times volume. Use 920 kilograms per meter cubed for the density. Then multiply by 300 meters and 4,200 meters. That gives 1.16 times 10 to the 9 kilograms. The question says about 1.2 times 10 to the 9 kilograms. Our value rounds to that. For the marks, the examiner wants to see the substitution, or an answer to at least 3 significant figures. So don't just write the final number. The exam technique is the important part. Spot the density relationship, rearrange it if needed, use the volume carefully, and always include the unit. That is how a short density formula becomes a full 2-mark answer. Before we finish, remember this is how density questions usually give marks. Write the formula first, then show your substitution clearly. The examiner needs to see your method, not only the final number. If the question says about round your answer to match it, here, 1.16 times 10 to the 9 becomes about 1.2 times 10 to the 9 kilograms. For topic-by-topic practice, step-by-step solutions, and smart paper building, head to eduninja.net and keep practicing with real exam questions.